Hey, hello guys. Welcome to another class where we are discussing vectors in our series, The Phenomenal Physics. So, we have already learned about dot vector, right? We were discussing in which way can we multiply vectors, right? So, we have already learned about dot vector. So, what did we learn? That if A is a vector and we are dot producting it with another vector, so it gives you a scalar quantity which is modulus of A vector, modulus of B vector, cos of theta, which is a scalar quantity, right? So when we are multiplying a vector dotted with a vector, it gives you a scalar. So that was our dot product. Now there is another type of product which we call the cross product. What is that? The symbol is like any other mathematical multiplication symbol, that is this x, the cross. That is why we call it a cross product. Now its definition is that modulus of A, magnitude of B, sine of the angle included between them, and the cross product of two vectors is a vector quantity. So right now whatever we have written, this is the scalar, it's a scalar quantity. So it also has one n cap. What is this n cap? So it is the unit vector perpendicular to both a cap, b cap. What is a cap, b cap? A cap, b cap is the unit vector along the directions of a vector along direction of v vector, right? And for this, how to find out n cap, there is a well-defined rule called the right hand thumb rule. So we'll go into this. So this is the right hand thumb rule. How to do it? Suppose two vectors are drawn, a vector, any general vector, b vector, another vector, correct? And these are drawn in which configuration? Where their tails are meeting. After translation of the two vectors, we have brought into such a position that it is meeting in some point O, right? We have already learned this during addition, subtraction of vectors, how to translate and bring it into the same tail configuration. So this is the same tail configuration. A vector is there, b vector is there, right? So what will be A cross B vector's direction? Magnitude we already know. Modulus of A, modulus of B, into sine of theta, right? What will be theta? This is the included angle between them, so sine of this angle we were talking about. What is the direction of this n cap? Direction of this n cap will be followed by the right hand thumb rule. Right hand thumb rule. Always remember this. So you place from the meeting point of the two tails, that is O, you place your hand from there pointed in direction of A vector. Why A vector? Since we are doing A cross B. So the first vector, you first point your hand in the direction of the first vector. Okay, not in any order. A cross B is not B cross A. We'll come to that later. So order is very important. The order of multiplication is very important. Remember this in this case. Okay, so whichever is the first vector, A vector, you point your hand towards that. Now where is the second vector? B vector is the second vector. You curl your hand towards the second vector. Okay, from this to this. This is the direction of curling of your hands, right? See how the hands are curled. This is how your hand should be curled. And whichever way your thumb will be pointing, that is this upwards, that is the direction of n cap, which will be the direction of A vector cross B vector. The unit vector will be pointing in that direction, and hence A cross B vector will point in the same direction, right? And you can see that this n cap is perpendicular to the plane. This is the plane, right, containing A vector and B vector both. So n cap is perpendicular to both A vector, perpendicular to A vector and B vector, right? So at the same time. But how to get in which direction it is pointing? See, n vector could have been this also. This direction is also perpendicular to a vector and b vector. So the right hand thumb rule fixes the direction, that it can't be in the 180 degree opposite direction. It has to be in this direction. The way you are curling your right hand, remember right hand, not left hand. Sometimes many of you curled with the left hand in the initial days. I also did this. So when you are curling your right hand, all the 4 fingers from the first vector to the second vector, the direction your thumb is pointing is the direction of the final product or the cross product vector. Okay, that is a vector cross v vector, or the unit vector along that direction, that is n vector. Okay, remember that. Okay, so now we already have that. So in Cartesian terms, we multiplied a vector dot b vector, we did, right? If it is xi plus xi plus ayj plus azk, 3 components, 3 unit vectors dotted with bxi plus byj plus bzk. You had practiced this, na? What we got, the scalar quantity x bx, individual components are multiplied, this with x, y with y, z with z. We just have to multiply the individual components of the corresponding vectors and add them up. Ay by multiplying the y components plus again multiplying the z components, and that will go on for any n dimensions. We have learned that. So in Cartesian terms, what will be the cross product of a cross b? What will be that? Xi plus ayj plus azk cross product bxi plus byj plus bzk. You can individually cross product. You can do the cross product, right? How? First term with this, then first term with this, first term with this, like you do in algebra. Simply x bx will be the scalar terms that will come up first, but the vector terms, that is the unit vectors, I cross I will remain. Then ax by I cross j. Okay, the scalar terms will come out. They are simple multiplication of a scalar with another vector quantity, which is the cross product of the unit vectors. That is how you have to do, simple algebraic way that you do. X bz I cross k, right, plus ay bx j cross I plus ay by j cross j plus ay bz j cross k. It's getting hectic, right? It will get finished quickly, don't worry. K cross I plus, remember the order is very important, that you please make sure you are not writing I cross k in terms of k cross I. It's not the simple multiplication of scalar, okay, or even dot product. In dot product, a dot b is b dot a. Right now we'll see that it's not the same. Just wait a bit. Az by k cross j plus a z bz k cross k. Now what is the cross product of these unit vectors? These unit vectors we know are perpendicular, mutually perpendicular to each other, right? So we'll just see. We'll draw it in a I cap is pointing along x, y is pointing along j. This is a right hand coordinate system, right hand Cartesian coordinate system. Why? Because here if you go in the direction of x, from x to y, the z direction will be pointing along the right hand thumb. Okay, so that's why it is called what it is called. Please remember, right handed Cartesian coordinate system. Okay, this is called. So along Z, no requirement of this cap. Along Z there is k cap. Correct. An angle between each of these is 90 degree. You already know that they are mutually perpendicular, right? So what is I cross I vector, I cap cross I cap? What is that? Cross multiplying with the same vector. It will be modulus of I sine of the included angle, that is 0 degree. Correct. And the from I to I, what will be the perpendicular to it? It is k cap, right? So this in fact is 0. Correct. If it is I cross j, what will happen? Modulus of I cap, modulus of j cap, sine of, now between I and j, between x and y, there is 90 degrees. And along which, if you take from I to j, the thumb will point towards z axis, that is k cap. So this modulus of I is 1, any unit vector modulus is 1, sine 90 is 1. So I cross j is k cap. Correct. What is then j cross I? J cross I is same, modulus of j, modulus of I, sine of 90 degree. But now which way? Your right hand 4 fingers are going from y axis to x axis, and now the thumb is pointing towards the negative z. Along the negative z, what is the unit vector? Unit vector is minus k cap. Correct. Opposite to k cap, right? So what does it become? So j cross I is minus k cap. So that is very important. Understood? So likewise, so what did we get? Any results we are trying to derive from here? One result we are getting straightforward is that if we are cross multiplying the same vector with itself, then we will get a 0. 0 what? 0 vector, not 0, because vector crossed with a vector gives a vector. So you just can't write a 0 on the right hand side. You have to write a 0 vector. Magnitude is 0 itself, okay? But it's a vector. We'll discuss about 0 vector in the next session. Right now we'll concentrate on the cross product. Okay, so first thing is cross product of a vector with itself gives a 0 vector. And if we are writing A vector cross B vector, that is not the same as B cross A. Why? Because modulus is same. Modulus will be same. Mod A, mod B, sine theta. The only difference is in the direction. The direction of A cross B, if this directs along n cap, its direction will be minus n cap, right? So A cross B is not the same as B cross A. Correct? Is not the same as the dot product, where dot product A dot B is same as B dot A, since both are scalar. But since it's a vector, the final product in cross product is a vector, and a vector is linked with a direction, and the direction is given by the right hand thumb rule. So from what is the first vector, you're cross producting with the second vector. The order is very important. Always remember this. Okay. Other than that, it is distributive. Distributiveness is there over plus or minus sign. Cross B. Okay, it distributes itself over the plus sign or the minus sign. So distributive nature is there. Correct. And since we are getting a vector, we can keep on multiplying more and more and more vectors one after the another. For example, we can't write A dot B dot C dot D, even if we give brackets that will do this first and then this. Why? Because once you do any dot product, it will become a scalar. Correct. And then there is nothing called a dot product between a scalar and a vector. Correct. Whereas between two vectors, once we do cross product, this gives a vector itself, right? Then we can do a cross product with that vector, another vector will get, and then we can do cross product with that. So this can continue, right? So infinite series of multiplications in terms of cross product can go on for vectors, which is limited to this dot product. Since after doing one dot product we get a scalar, and then scalar you can get directly multiplied. We have already learned multiplying a scalar with a vector, but that is not the same as dot product. Correct. Multiplying a scalar will just scale up the magnitude of a vector, no change in the direction unless and until the sign is positive. If the sign is negative, the vector's direction just gets rotated by 180 degrees. We all know that. Okay. Okay, so we'll complete whatever we were doing in the Cartesian coordinates, that is this multiplication. What does it result? So this now we'll jag in all the values that we are getting as a result of cross multiplying the dot product, that is the unit vectors, right? So multiplying with itself, cross product with itself is a 0, right? And the rest, all magnitudes will be 1 or -1 with some unit vector pointing in the right hand thumb direction accordingly. I cross j, that we know is a k cap, j cross I is a minus k cap. So once we write that down, we get in a very simplified way, which you can remember. Otherwise this big expression, it's very difficult to remember. You can use the thing called matrix, or better, determinant. So A cross B, to remember it's very simple. This is the symbol of a determinant matrix. I, J, K, give the cap symbols. Now whichever is the first, write down in the second row. This is first row, you know the row, na? These things are called rows in matrix or determinants. AX, AY, AZ. Corresponding to I cap, you write down the X component corresponding to J cap, Y component, and corresponding to K, you write the Z. And then in the third row, so this is the second row. Second row, you write whichever is the first vector in the multiplication in the product, and whichever is the second in the product, you write down last in the last row. BX, BY, BZ in the third row. Okay. So this itself is the explanation of A cross B. So what does it give? I cap AY BZ, multiply this first, minus AZ BY. This positive, this negative. Correct. Then second is minus J cap AX BZ minus AZ BX. Just hide the Y components and go in the similar fashion for the left hand column and the right hand column. Then plus K cap AX BY minus AY BX. So this is the final result or the final vector. Three unit vectors are there, 3 components are there along the 3 direction. So this is a vector quantity. Modulus you will get by square root of the X component square, square root of the Y component square, square root of the square of the X, Y and Z component square, then square root of that. Okay, you can get the modulus. Okay, so this is all about the cross product. So if there are these 2 vectors, let me draw it. And this is one vector, this another vector, right? Tails together. So A vector, this is B vector. Correct. So cross product of it, A cross B. will be, while we are going from here to here, the direction of A cross B will be along this direction, right? Correct. What will be the direction of B cross A while we are going from this direction to this direction? With our right hand, the right hand thumb will point towards this direction. Correct. Now we already know that the moduluses, the magnitudes are same. Why? Because both are consist of multiplying the magnitudes of the two vectors with the sine of the included angle. Now sine of the included angle will remain theta for both directions, in whichever A to B you go or B to A you go. Doesn't matter. Correct. Only that if along A cross B vector, suppose unit vector along this is n cap, then along this it will be 180 degree opposite, it will be minus n cap. So A cross B is suppose modulus of A modulus of B sine theta n cap, right, which is negative of modulus A modulus of B sine theta with minus n cap. Minus n cap modulus of A modulus of B is what? Minus of B cross A. So A cross B is nothing but B cross A with a negative sign. Means the modulus will be same, the magnitudes or the length of the vector you are drawing, that is same, only their directions are opposite to each other. This is of loads of use in physics, believe me. You'll learn it in magnetic fields. So many places this cross product will come later into use in electromagnetic waves. It's a lot of use. So practice problems on this and we'll meet in the next class. In the next class I will talk about this zero vector, that where I stopped. If you think about it, why I stopped over there, why this zero vector, can zero be a vector or not? Just think about it. Okay then, so you know what you have to do. If you like it, please press the like button, and if you indeed feel that you can learn something from this channel, then please go on and hit the subscribe button. I will bring videos up to you. I want you to succeed in your classes 11-12 boards, and also develop some kind of knowledge of physics, not just for JEEs or IEEE or getting into IITs, NITs, cracking some Olympiads. That's okay. But in real life, if you really love physics, ultimately, this can be a very good forum. And I want this to turn into a good forum where we can discuss. And how to make that happen, you have to comment. Please comment about what you think about this channel, what more should I give, any specific topics that you want to learn. Okay guys, so keep on studying and keep on learning and loving physics. Don't get bored of it. You just have to try a bit hard, because you have come into 11-12, certain extra things in mathematics you have to learn that side by side. Okay, like derivatives, integrals, small things only, and then it will give you results in the future. Okay, so that's enough. It's getting a long video. We'll meet in the next class. Till then, goodbye.